So how do we win in Chaos Corner? Over here where the start is. I like this picture just because it gives you a really good vantage point of the racing area and gives you the opportunity to notice a lot of things. You can see how the swell energy and the wave energy comes into the breakwater and then refracts or whatever it does, and you can see how it curves like this as it fills in. So this is actually a surf spot here on this side, and so is this on this side. When the swell's right, the waves will break down both breakwaters. I think the main point there is just to illustrate how chaotic Chaos Corner really is, right? You can have full-on surf spots on both sides and current going in and out, and then you've got the toilet bowl whirlpool effect of the current going on over here. But you can also kind of see the texture on the water in the channel here is a little different than in the corner. And that's because you can actually see the river, right? You can actually see the current probably going in, but maybe going out. And you can see there's a well-defined current line right here, right? And a well-defined current line here. And then it's probably doing the opposite. You can see this white stuff here. This is potentially the current switching around and going the other way for us right there. Look at this narrow channel here. Okay, the channel's pretty narrow the whole way through. So you got to figure that's a lot of water that has to move in and out through a short space. So what's that do to the current? Well, first effect on the current is it's gonna make it really strong really fast. It's just what has to happen when a lot of water has to go through a small space in a short period of time. And then you're gonna get eddies off of all the peninsulas and stuff like that. But really we want to talk about how the high tide and the low tide and the current, the flood and the ebb, how those relate to each other and how they interact. So we've already kind of looked at this. We have low tide at 8 o'clock on Saturday morning and high tide at 1:30. So it should be flooding throughout that entire time period. But I think it's going to continue to flood even after the high tide a little bit. Like the current will take a little bit longer to fill in through all that, through that harbor than the tide will take to reach high tide, right? So it'll take a little longer for the current to fill in. So it'll be good for you guys to figure out how to read one of these. What does a tide chart mean? What are all these waves? And what's this chart mean? So here's the time of day on the bottom. Okay, here's the date on the top as well. And here's the height of the tide, right? 0-foot tide's a really low tide, a 4-foot tide's a pretty high tide for California and Southern California. As you get closer to the equator, the tides are going to get smaller, right? There's almost no tides at all right along the equator. And as you get closer to the poles, as you go farther and farther north and farther south, if you go to a regatta in Seattle, you're going to have 10-foot tides or 12-foot tides, or if you go to Canada, you'll have huge tides and more current, so all that plays a big factor. So I want to draw your attention to the way this wave, the line of this wave is drawn, right? How it curves at the bottom and then gets straight here in between, and then it curves at the top and then gets pretty straight here in between, and then it curves again at the bottom, right? So what does that mean? You guys see what I'm getting at? Oh, that was a bad draw. So these are straight lines, right? How come this chart curves instead of just being straight lines in a zigzag from trough to crest, right? And what's the significance? of that. What does it represent differently? Okay, that's supposed to be a straight line, right? Perfectly straight line. Okay. So what's the difference between a graph that has a perfectly straight zigzag line that just goes top to bottom and the curved graph, right, that we see underneath? And the answer is the rate of change, right? What we're noticing, or what this graph is suggesting to us, is that in this area over here, not a lot's going on, and things are pretty still, things are pretty calm, not a lot of change is happening, right? Especially up here at the top, right? Things are very, very still here, not a whole lot's going on, okay? And then when we get to this part, okay, then that's when we have the maximum rate of change, right? That's when the tide is changing at the fastest, okay? That's when the current is likely going to be the strongest, okay? And then down here at the bottom, things mellow out again, and they kind of, this curve is a slowdown in the movement, okay? Whereas these straight lines, okay, if it was represented by these straight lines that are just a zigzag, that representation of the data would say that the rate of change is constant, that the tide is going in, or the current is going in and the tide's going up at a constant fixed rate, and then it hits high tide and then immediately starts to go down at a constant fixed rate, okay? So that's something that a lot of people overlook when they're thinking about tides and current, and this importance of it and the significance of it is that at the end of a tide cycle, at the high tide or the low tide, usually you've got like a 2-hour period where not much is going to happen. Okay, you've got a 2-hour slack tide, slack current period where the tide's going to hang out at high tide for a while. The current will finish filling in as the tide hangs out there, right? So at this part of the chart right here, I wouldn't be surprised if this current is still going in even though we're starting to ebb, okay, even though the tide's starting to go out, because I think the current will follow it by a while because it's going to take so long to fill into the narrow channel at Morro Bay. Okay, so we'll have this slack tide here, and then we'll have this really huge current swing here, right? If that makes sense. Okay, so going into Saturday here, you see we're starting the day at like 6:30, 7 o'clock. We're starting at a low tide. Okay, and this is going to be kind of slack tide mellow. Okay, but then by the time we're showing up at the venue, like 9 o'clock here, we're going to be in full fast rapid current change mode all the way to this time, right? Okay, and that's going to be a flood tide. Tide's getting higher, water's coming into the bay, and it's flowing in and around the harbor. So we have that flood tide diagram from the other video going on the race course. But then at around 1 o'clock, it's going to finish flooding in, the tide's going to stop rising, and we'll have a slack tide probably for like an hour or two, okay? I would say that we're never going to ever have a total current-free race. There's always going to be current on the race. And in this slack tide period between the flood and the ebb, I'm not really sure what's going to happen. So you really need to be vigilant about doing your research for yourself and checking things out for yourself.